Welcome to this episode of Robert's Creative Chronicles. So today we are going to solve this question, which states that solve the following linear differential equations, A and B. So a linear differential equation is given by this formula, dy over dx plus py equals q. So we have to rearrange this equation into this form. To rearrange equation A into this form, we're going to divide through equation A by tan x. So we divide this by tan x, gives us dy over dx plus 1 over tan x y equals sec x over tan x. Now, this sec x is 1 over cos. Tan is sine over cos. So we're going to rework it to simplify it. Y over dx plus 1 over tan x y equals what? Sec is 1 over cos x. Then divided by tan. Tan is sine over cos. So we'll rearrange it. Instead of dividing it, we'll rearrange it so it will be times cos x over sine x. Formerly it was divided by sine x over cos x, but if you rearrange it to give you, and you multiply it to give you cos x over sine x. Now this cos and this cos will cancel. It becomes y over dx plus this 1 over tan is cot. So it becomes cot x y equals 1 over sine, which is what? Cosec x. So this is the equation. Now we'll find p and q now. We'll relate this equation 2 with equation 1. So our p now becomes what? The one that is attached to y, which is p is cot x and q is what? Cosec x. Normally p and q can be constants or function of x only. So these p and q are usually constants or function of x only. So we'll find the integral of p with respect to x, which is integral of cot x dx. Now the integral of cot x dx is what? In sine x. Okay. First, then the second thing, the next thing we're going to do is we're going to introduce an integrating factor. Integrating factor called if. This integrating factor is exponential p dx. Now, what's exponential p dx? That is exponent of in sine x. Since this integral of p dx is in sine x. And the exponent of in sine x is what? Is sine x. So our integrating factor is sine x. So now we're going to substitute this integrating factor and this q into an equation to solve this differential equation. The equation is this: y exponent of p dx, which is the integrating factor, equals integral of q p dx x. So this equation 3 is what we are going to use this equation 3 is what we are going to use to solve our linear differential equation. So now this becomes what? Y sine x equals cos q. Q is cosec x. Then sine x, that is dot sine x dx. So this becomes y sine x equals this cosec x, what is 1 over sine 1 over sine x times sine x x. So y sine x equals, when this and this will cancel, it becomes integral of what? D of x. Only 1 becomes 1. So this and this will cancel, it will give us 1. So it will be integral of dx, 1 dx. So y sine x equals what? The integral of 1 x. So this becomes y equals x over sine x. And remember, when you integrate it, you put plus c. So this one will be plus c. So this becomes what? Y equals x plus c. Inverse of sine is what? Cosec x. So this is the answer for the A part. So here's the B part. And the B part, unlike the A part, the B part is more like a linear differential equation. So y over dx plus py equals q. This is the linear differential equation, and we can directly compare it to the equation. So from this, by comparing this, from these two equations, p equals 1, that is the coefficient of y, and q equals exponential x. So the integral of p dx equals to integral of 1 dx, which is equal to x. Then the integrating factor, exponent, and the integrating factor, which is exponential integral of p dx equals exponential x. So this is the integrating factor, exponential x. Then we'll go straight to substitute this integrating factor and q into the equation. Y exponential integral of p dx equals integral of q exponential integral of p dx. So it becomes y exponential x plus integral of exponential what? Exponential q is exponential x. So, and also this one is exponential x dx. So y exponential x, by law of indices, this one equals e x plus x dx. This becomes 2x. So if we find the integral of this, we first differentiate 2x becomes 2, then we will divide it. We'll divide the function by 2 plus c. So this becomes 1 over exponential x e to x over 2 plus. So this is the final answer for the B part. And please note that this equation, you add the x to it. Yes, I added it already, so just for formality's sake, yes, just add it to it. I've already added it here. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email within the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share, and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.